if it's in mixed case, and hopenpgp if it's all lowercase. So I was told I needed to have something about me, so if you don't know who I am, I'm the guy giving the talk. And apparently I started this back in March 2012 because I wanted to use openpgp with TLS, and it seemed like it would be easiest to do both client and server in Haskell, and boy was I wrong. But Haskell is great, and I was not aware of any options other than one set of bindings to GPGme. And GPGme was suboptimal for various reasons, and even though there's now a better set of bindings for GPGme, it's still got the limitations of GPGme itself, and I think it's still useful to have a separate implementation. So in 2011, two different people independently started writing openpgp implementations, one of whom actually wanted to do the same stuff with RFC 6091, and that's how we found out about our competing projects, and we've made a slight effort to merge our code bases, but it's proven to be difficult for various reasons, and basically we now just share a test suite, and it's possible that will be improved in future. So it's really difficult to have a program make use of openpgp, because you either have to shell out to GNU-PG itself, or you use GPGme, which is a library that shells out to GNU-PG with a different API, and I think that's why there's like 15 different Python libraries for openpgp, and only 2 of them use GPGme, and the rest call GPG directly. So one of the problems, or one of the frequent complaints about GNU-PG is that it's difficult to use, so a library that's not difficult to use would theoretically be useful for making easier to use interfaces. And of course, I enjoy threads on Debian project about key size and hash algorithms, and having a library to facilitate that is pretty great. So there are 3 components in the suite. hopenpgp and openpgp-asciiarmor are the libraries, and hopenpgp-tools are the tools. They're available from Hackage, Sackage, and Debian, and nowhere else that I'm aware of. openpgp-asciiarmor is pretty boring. It's the ASCII-armor codec. It's been unchanged since sometime in 2012, I think. And it is, I think, the only Haskell implementation. Everybody else just uses it, and even though it could be improved, nobody has pushed for it to be changed. So maybe that will happen in future. hopenpgp is more interesting. It does the rest of RFC 4880, compression signatures. It's kind of a beast. It's not entirely portable because it uses Haskell features that are not present on all of Debian's architectures, and the API keeps changing and is going to keep changing for the foreseeable future. So yesterday, Zach asked me if I was going into the internals, and I said I wasn't because I hadn't thought of a good way to do that. But since this is the functional programming track and it's about Haskell, I'm now going to show you how some of this works. So this is a data type called TK. TK stands for transferable key. It represents a transferable public or secret key as defined by RFC 4880. And it mostly mirrors the binary structure of such a series of packets, which is the public or secret key, represented by the pair on top, any number of replication signatures, any number of UIDs and their corresponding certifications, any number of user attribute sets and their corresponding certifications, and any subkeys. So probably some of these should be non-empty lists instead of lists. The brackets represent lists of whatever type's inside, and the parentheses and commas represent tuples, which in this case are all pairs. So we could, with the type system, actually say that some of these are not allowed to be empty. They need at least one element. So at some point in the future, I'll probably do that for correctness sake. And the last line of the data declaration, which is in record syntax, is for automatically deriving instances of type classes. So the EC and show type classes allow you to compare for equality and convert to string, respectively. And GHC will derive those automatically if it knows how. And in this case, it does, because each of the types contained within this structure also have the corresponding instances. But for ORD, which is a class that allows you to see whether something is less than, greater than, or equal, we're defining this by hand. And so we're saying that a transferable key gets ordered solely on the basis of the contents of the public or secret key. So that may not be the best idea, but that's what's happening now. Did any of the non-Haskellers understand any of that? Okay. So we're also defining an instance for indexable, which is how I've chosen to represent keyrings for now. So we make an indexable set of all the keys you insert, and then we have an index for the UIDs, the 20-octet fingerprints, the 8-octet key IDs, and the entire public key payload itself, which is probably the cause of DKG's laptop heating up and spinning for 90 minutes at a time. But we can work on that later. And then this is the semigroup instance. This is a semigroup is a set with an associative binary operator. For a long time, I wanted to make a monoid, but I couldn't figure out how to do the identity element. So I made a semigroup instead. So this says how to basically merge two keys. So if you have key A and key B, we're going to take the public or secret key from key A, and we're just going to throw away that part from key B. And then for the revocations, UIDs, UATs, and subkeys, we're just going to merge them together with the functions at the bottom in the where clause there. So
I should have been NSA.
Yeah, why is the NSA in there?
Yeah.
Why
it's
NSA in there.
It's an
Every Haskell program has to.
Just to see if we're paying attention.
right. So that's just an abbreviation for nub sort append, but we need more conspiracy theories. It's true. So this is going to be theoretically useful for if somebody wants to build a tool to fetch keys from a key server and then just merge the new signatures onto an existing key or something like that. And so the very first thing I had to do after defining a bunch of types was serialization. So actually the serialization was less important than the parsing part, which is the next slide. But so this expresses how to write out a public key payload, which is most of the public key, to a byte string. And so on top we have a v3 key. So it outputs the octet 3 to show that it's a v3 key, and then it has a big endian creation time and the v3 expiration and the public key algorithm and the public key itself. And the reason we do put pka instead of a more specialized function is that there's a put instance for public key algorithms already, and so we can just use that. And on the bottom, it's a v4 key, and we're just throwing away the v3 expiration field because it's not relevant. So that helps produce a byte string from a key, and this is the other direction. This will parse a public key payload. So this is using the serial library, and if the binary library continues to improve, it might be good to switch to that instead. So this, yes.
I'm curious about why you have the public key algorithm separate from the public key object, given that it seems like the public key object could know its own algorithm, or would that?
So the way the types are somewhat of a rat's nest. You're as What are you asking exactly?
I'm not a Haskell programmer.
Okay, how about we come back to that
Okay.
at the end or something. So this is the inverse operation. We're grabbing an octet to find out the version. Then we're grabbing the creation time. And then, depending on the value of the version, we either read a v3 or a v4 key. I had to change it to accept a version of 2 because there's all kinds of weird things on the key servers, and I was trying to parse as much of it as possible, and there are a lot of keys with that value, and they seem to be exactly like v3 keys, but I'm not sure. So that might be something to figure out later. And at the end, it's going to come back with either a v3 or a v4 key, or fail entirely because it's a new or invalid key format. So now we segue into the command line tools themselves, which some of you have been using and may be of more general interest. So HKT is the hopenpgp keyring tool, and right now you can export keys, list them, and then you can also graph certifications and find paths between keys. This is something Dav asked me about at Hope, and it was easier than I thought to implement. So an example of HKT is we can take the Debian keyring and list all keys with a creation time greater than January 1st of this year. So you can see all the keys in the Debian keyring that were created this year. So there's 2 different ways to specify keys with this tool. Well, you can either do a long key ID, full fingerprint, a user ID substring, or a filter expression, which is this basically a DSL I wrote that needs to be totally overhauled, but lets you do things like numeric compare on the timestamp. So probably the most popular tool right now is hokey, which has one subcommand, which is lint, and that aims to let you know how you're doing with regard to the OpenPGP best practices document published by RiseUp. So you can either use HKT to export a key and pipe it to hokey, or you can use GPG. It takes a transferable key in RFC 4880 format in OpenPGP packets. So any compliant tool that exports a key in that format can be used as a source, and you can get output with pretty colors, or you can get it in JSON or YAML if you change the output format. And so if you read any of the messages on Debian project where I posted some statistics that came from the JSON output and post-processing with JQ. So this example will export all RSA keys greater than 8K from the Debian keyring, which I think is just 1 or 2, and complain about how his expiration date is too far in the future. So now there's hot, which is meant to operate on either ASCII-armor or individual openpgp packets. So there's a filtering here that operates without context. So, and the syntax is also suboptimal for historical reasons that should be fixed. So, if we do the same export again to get the person with the big key, and we pipe it to hot filter, we have to specify filters for pub keys, signatures, and other packets, which is really not ideal. But if you don't do that, it's gonna just let them all through. And in this example, I want only signature packets that are positive certifications, and I wanna dump them to the screen. So this also probably needs an overhaul, so you can specify that filter without 3 different command line switches. So I talked briefly about the graphing done by HKT. So this is the KSP keyring built by Anibal prior to the conference, and you can't really see what's going on here, but so the graph command outputs a file in, or not a file, it outputs dot, or I don't really know the difference between dot and graphviz formats, so perhaps they're the same, but
Dot is one of the formats of graphviz.
okay. All right, so it outputs something that can be rendered by dot, and then you can convert it into an image. And so
How many CPUs did you melt for that?
not many. This didn't take. This is a small keyring. If you try to do this on the Debian keyring or your personal keyring, you're going to be in a lot of pain. But we might be able to optimize that. The other thing is that this is purely a self-contained operation. It's verifying signatures on this keyring from this keyring. So anybody not in the KSP list is not going to be used as a connector. So this is all pretty self-connected, and then this stuff up here. Well, actually, so I had to zoom in here so you could see. So this is each arrow represents a certification that's verified and valid according to the logic we're currently using, which may be flawed. And so number 23 up there is Anibal's, I forget which key, but one of him. And I guess that should be pretty self-explanatory. And then, yes.
Yes. Is that image up anywhere on the internet?
Not yet.
Okay. Can it be?
This specific image?
Not this one, the full image.
But
they can't be.
I mean, you could generate it yourself and publish it.
Clint, what versions of openpgp-tools are your examples drawn from? Will they work in the versions that are in Jesse?
So, unfortunately, Jesse.
I don't like that way to answer. To start
Yes. So these are from the Jesse version. I'm using an unreleased version for pathfinding a little bit later because I am apparently a hypocrite and can't release early and release often. So So that's nice, healthy connections, and then the upper right is people who are in either solo or pairs, and you can see that the pairs on the right side are bidirectionally certified, and on the left they're just one way. So you can also find paths in this keyring, and it uses a Dijkstra pathfinding algorithm to determine the shortest paths. And so there were 4 paths that were 7 hops, and they all start with key 118, which in this case is one of Yixuan's keys, and you can see the path from him to the 4 people on the right. So, and for some reason, LaTeX lets me do Unicode characters for some things and not for others, so this has been sanitized a little.
Question? So could you in theory use this to figure out which the most advantageous mutual key signings would be?
Yes.
Repeat the question.
Sorry, Dav asked that if you could use this to see what the most advantageous key signings would be, and I think so. And I've actually been specifically targeting people here if they are at maximum hops for me. You can also use it to find your path to someone else for the usual reasons, I guess. You can also use the same output to see the nexuses of paths, and so this is as of this morning, which all of these numbers have gone up since the beginning of the conference, and actually T-Marble and Tumbleweed had switched places just this morning. So it's a race.
What do those numbers mean?
Yeah.
So the number on the left is it's an ID number. It's the same as in the previous slides. It's just arbitrary ID after whatever ordering was done to make the graph, and it's static within this keyring. And then the right side is how many of the paths from everybody, or from each person to each other person, contained that key as a middle hop. So, there are 592 paths from someone to someone else that go through Paul tag.
Shortest paths or just paths in general?
Shortest paths.
Okay. How does it deal with 2 equal length paths? Do those count twice?
Please repeat.
Daniel asked how it deals with 2 equally long paths, and I believe it should give you both, but I am not sure. So these should look a little more familiar if you read Debian project. So there were 123 keys in the KSP keyring. One of them is DSA. 2 of them are 8K. One of them 16K. 2 of them have what RiseUp considers a weak hash with a higher preference on the hash preferences subpacket, and there's still controversy about expiration times, but according to the guidelines, this is how they stack up. And this is about user IDs and user attributes. And someone is using RIPE-MD 160 for self-sigs, and most people are not. And
So this is more than there are keys. Is that because it's per self-sig on each
This
sub-key
is-
as well as user ID?
yes, this is each valid certification for each UID or UAT. So if you
But
have
not for sub-keys.
yes, not for sub-keys.
Okay.
So there's that. And so with the tools, you can also do what-if scenarios. So the top is the strong connectivity of the KSP keyring on August 21st. And so there's 87 people in a strong set and 2 pairs, which I think are probably just one person each with 2 keys that are cross-signed, but might not be. And if you filter out all RIPE-MD 160 and SHA-1 signatures, that strong set drops down to 69 keys. So you can see how the web of trust might be strengthened or weakened by various operations. And so over the conference, I think each of those top numbers has gone up by about 8, and the one of the 2 clusters has disappeared entirely. So we're gaining strong connectivity throughout the conference. So, all right. So there's someone working on using the hopenpgp and openpgp-asciiarmor libraries in the Hackage server and Cabal. I don't know how that'll turn out, but there's a branch you can look at if you're interested. I would like to see more. Yes, Eric.
What's Hackage?
So Hackage is a software distribution system for Haskell. It's like CPAN or the Cheese Shop or whatever Ruby has. And then Cabal is the tool equivalent to pip or gem or CPAN or what have you to fetch and build and install software. So I'd like to see further work trying to reduce duplicated effort with the OpenPGP library. Daniel has asked for some sort of key canonicalizer so keys can be diffed more easily. The API needs improvements. We have the potential for other language bindings because Haskell has a bidirectional foreign function interface, so we can come up with a C API for the Haskell library, and then any other language with a C API, FFI can theoretically bind to hopenpgp through that. The hard part, I believe, will be coming up with APIs that make sense. So if anybody has any ideas about that, that'd be great. People want to make GUIs. I'd be happy about that. Keyring operations are a pain, so if somebody can come up with a better way to store keys on disk so that they're easily, no?
I agree.
Okay. Yes.
So we were playing around with the GPG 2.1 this week, and it's got a new disk format called Keybox, which I'm guessing your tool doesn't support yet.
Yeah, that's right. I looked at Keybox a little, and I forget the details, but it seemed like it wouldn't help, but maybe I misunderstood it.
What would Oh, for performance, you mean?
Yeah. So, the difficulty is the performance problem I'm alluding to is with indexing a whole bunch of keys and then retrieving them from wherever they're indexed. So another idea Daniel had was validating key server that would only accept valid keys and signatures through cryptographic verification.
Just
Except SKS, which will then screw it up.
Right. So yes, there are problems if you want to gossip with the SKS protocol.
But for background, none of the public key servers do any cryptographic verification of keys at all.
No, they don't. I actually run one of the SKS key servers on the network.
Yep, and none of them do cryptographic verification. So the idea here is that maybe we could think about setting up key servers that did that, and then they would not actually probably gossip with SKS because they wouldn't be able to accept some of the things that are on the SKS key servers.
Right.
So I do very limited hash verification in my key server, not the full validating the signature, but making sure that there's a 2 bytes which basically say the hash function that then you can use to say yes, this hash is actually valid, and throw away a signature that is obviously not the right one, and particularly that's useful for the subkey damage that PKS used to do. So I have got there, but my main issue with doing validating key servers is how do you then form a key server network where the keys are different on different key servers, and that's already causing me problems as someone running a non-SKS key server.
If you talk loudly, the room mics should pick it up, so you don't necessarily need a less room mic.
I noticed you didn't talk about implementing a GPG-compatible interface on the previous slide. Are you interested in doing that? Is that something that might happen? I say this particularly because hypothetically, it would be good if something like the GPG extensions for Thunderbird would use hopenpgp instead.
So my focus thus far has been to try to do things that GPG can't do or doesn't do well. I have no objection to people trying to write a GPG clone, but for now it's more interesting for me to have a tool that can do something I can't do. Joey?
Yeah, have you looked into how well you handle encryption and decryption, right?
To some extent, yeah.
Yeah, I mean, have you looked at, are there incompatibilities? I don't know how good a standard openpgp is as standards go.
So far, there's a test suite which needs more tests, but much of the data in the test suite has been produced by GNU PG, and then there's stuff pulled off the key servers. So there's a lot of sanity checking against real world data. I forgot the original question. So.
Well, I was wondering, you're clearly using it a lot for key management and analysis, but what about actually using it to encrypt and decrypt data? And old GPG other than...
Yeah, other than like test cases, I haven't really done that. There was a little while I was working on secret key decryption because I wanted to use a stronger cipher for my secret key, and I thought I couldn't redo a cipher with GPG, but then it turned out I could. So the decryption support is there, but not the re-encryption. Mostly for fear reasons, I haven't really been doing anything that's not read-only. So if you want to modify files, you have to redirect to another file and do it yourself. Yeah, if anyone would like to help contribute, there's some ideas, and I guess we can continue with questions now, or if anyone wants me to demo something, maybe I could try that. Or Micah.
Yes, sir. Can you show how you generated that set of keys that would be ideal to track down and sign here?
Yep. If I can figure out xrandr.
Like Jen, you showed a slide of all the keys. That would be ideal.
Anyone read that?
Nope.
No.
Yes.
Now I can get white.
Rather than sign it.
I'm just not that huge.
Bigger? Wow.
I think it's fine.
That's all right.
Okay. Is it?
Yeah.
Yeah, sorry.
Yeah, it can be, if you invert it, it'll be better.
Well, let me read
Well, perfectly for
Can
me.
you read it in the back row?
No, all right.
Yeah.
Better.
That's the stuff.
Okay, so you wanted the paths.
The paths that you were using to track down the people to sign.
Okay, so that's the command I use, and so find paths, keyring, we're doing, so there's 3 key selection things we're doing. The first is what subset of the keyring to use for pathfinding, and then the next one is which keys to use as a starting point, and then which keys to use as an ending point. So if we do any, we're using the entire keyring and finding paths from every person to every other person. But if you were just interested in your own key to somewhere else, you could slow that down. And this takes like a couple minutes, so
Well, if you can
I'm not
stream
gonna do it again.
You want to be quicker.
Can you do it from your key as a start point?
So,
Or it's slower, still slow?
it's going to be quicker for me to just use grep right now. So,
Which one of those any do you put your own?
the second one. But there's a problem with the syntax right now that won't let you do that.
Does the any work with what's out there in Jesse now, or is that?
No, this is, you can see the first word is, I'm using a locally built copy. But if you all nag me, I will upload the
Consider yourself nag?
Yeah,
please do it.
Not right now.
Live.
Can you use openpgp to sign your changes file and just upload it right now?
No. So, so actually, I should show you the output first, so this makes sense. Okay, so, and the left is cut off. Gee.
We know the projection.
Wow.
Rolling that.
Well, that's engineering. Okay, so each line is a tuple of, so the first number before the comma is the length of the path. This is just so I could sort. And then after the comma is a list of the shortest path as determined. So the first line is 1 to 1, which is 0 hops because it's self-signed. And then the second one is from 1 to 2, which is achieved by traversing key number 5, and then so on and so forth. And then at the bottom of the file, there's a mapping of the key number to the fingerprint, so you have some idea who those people might be. And obviously this could be made a lot more user-friendly if you wanted. So if you grep, so I'm number 6. So if you grep for any path that starts with 6 or ends with 6, you're gonna get. Thank you. So now I have all the paths from me or to me ordered by hops. So at the bottom, you can see that Guo Yishuan and I are furthest from each other, and then some other people are slightly closer. And so if you want to find who's farthest from you, that's how you do it.
But currently there is no way for me to do it before everybody leaves, because this is not yet committed.
It's committed. You can build it yourself.
The current version will give you those numbers. It won't give you the length, and it won't give you the fingerprint. So yes and no. If you can figure out who those people are, you can do it. Or actually, the change is in the Git repo, so you can build it yourself instead of waiting for me to upload the package. Anything else?
It's not dark.
But it's 45 minutes.
The source code is in Git, and the packaging is in darks.
That's true. Well, this is
Just to keep us on our toes.
Sadly, Joachim went home, or you could troll him about that right now. But yeah, everything we package in the Debian Haskell group has the Debian directory and darks. Almost everything. Eric.
Are there PHP bindings?
Not yet that I'm aware of. Anybody else?
Thanks for working on this, Clint.
Yeah, thanks.
Thank you.
Yeah.
Okay, well then, thank you for coming, and